I'd be interested to hear it in progress. I was tempted by the description of this as being a demonstration, so I wondered what I was going to see on a Saturday morning.
Okay, well, it is going to be a demonstration.
Excellent.
We are prepared to do that with you in about 10 minutes.
Right.
And we've set aside 20 minutes to go through the demo together. But this is the background. So our work is inspired by the questions procedure, which was introduced by Professor Borovic at the panel last year. We're going to illustrate it with 4 Jupyter notebooks. And hopefully there will be time for you to create copies yourself by cloning the REPL that Neil's constructed for session C. So what is the questions procedure and how does it fit? What Borovic said is, when confronted with the need to build a mathematical model of a word problem or to model the information aspects of a software system, the student or analysts ask themselves a series of questions. And you can read them on the slide there. And these extracts are taken from textbooks which are freely available on the web. So we draw a parallel between Guitegneu's early algebra approach to pedagogy in mathematics and Ligod and Joe Bergen's approach to teaching object-oriented programming. The major difference between what we're recommending or what we're investigating with traditional school computer science is that we don't start with language constructs, loops, variables, and so on, but we start from modeling a complex real-world domain as an algebraic or abstract data type. The first module is 6 lessons, and it should take 20 minutes if you're new to Haskell, or 5 minutes otherwise. And we look at the rod world, which ATM has consistently and continuously investigated since its invention in the 1950s. So in the rod world, the physical world, you have objects which are rods and trains made of rods put end to end. These objects have properties such as a name and a color. And there's a structure to the rod world, which you initially start by studying trains formed by putting rods end to end, the operation of plus. If you do the first module, as I say, it'll take about 20 minutes. If you're new to Haskell, it'll give you a feeling for the kind of teaching and learning materials that we're hoping to deploy for Key Stage 2 and Key Stage 3 teacher professional learning. The module ends, it introduces type classes to model the exercises in Guitegneu's numbers in color. Programming, as I say, is in a Haskell notebook, a Haskell Jupyter notebook. In a notebook, you have code cells which are executed in line and interposed with markdown cells, which are the text. And they take the learner through developing an algorithm to create the table of complements for any rod. Delegates new to Haskell but familiar with Cuisenaire rods should start with this module. The second module, the cherry ball problem, is also in Haskell, but this time we take the problem that was set by Professor Borovic last year as a canonical problem. David Vaccaro calls this the potato peeling problem. He has a slightly different version of it. But basically, you have 2 people. One can fill a ball in 8 minutes, the other one can fill it in 24 minutes. And the question is, how long will they take if they work together? Vaccaro put this question to ChatGPT, so if you're around for his talk, you'll see what that came up with. And the design of the workbook is 10 cells, where we invite the student to add their own equations, single line equation, to make a general purpose solution for that problem. In module 2, we move from the world of functions and types to the world of messagings and inheritance. And the transition is from pure functions to functions with side effects. So for those who need a refresher on side effects, there's a definition here of a Python function, which is passed the argument fruits, which is a list, and the effect of calling the fruit list, calling the fruit list function, the fruit function with side effects on the fruit list, is that it changes the parameter, the input parameter. So the parameter before is apple and oranges, and afterwards, because it's a mutable parameter, you've appended pear and banana to it, and it's changed the world outside. This is very useful when you're programming a simulation of the real world. So this is the basis for Bergman's 2 textbooks here. He takes the world of a robot moving around, picking up beepers at corners, which responds to functions which change the state of the world in the simulator. And the notebook is to take a problem where the robot's sitting here, and you have to write a program for it to move down, pick the beepers up, and stop at the bottom. This is in Python, obviously, and builds on the work documented in Joe's book. Again, to write the code, you go through the questions procedure. What do we know about where the robot Carol is sitting? Does any of this information provide insight toward the solution? What robot instruction can we use to keep him walking south until he reaches the southern boundary wall? My estimate is that it should take 10 minutes to do this if you are familiar with Python already. And it's an example of the questions method applied to software design. The final module, which is at the top here, is a game design. This is a game played against the computer. So the computer is the fox sitting here in the French military game. It's being attacked by 3 policemen or hunters, and it will be trapped when it can't move. It's blocked from moving in any of the possible directions. The police have to move from left to right. So they have to move from one side of the board to the other. The fox has to get to this point here, and it can move in any direction. The game is played by running a notebook, which sits in the module folder. The delegates are invited to explore the gameplay and begin to drill down into the documentation, which is described, the game is described in 10 pages of Bergen's book, and I've just transcoded some of the text from his book into a notebook. Now, this is the structure of his game. He's got rules that determine what's a legitimate move for the police and the fox. The fox uses those rules. The police uses those rules. The police also needs to know where the fox is. And then there's this thing called the memory manager, which recalls the history of games played. So the fox learns by consulting the history which move is more likely to lead to success, and the game becomes more difficult for the human user to beat the fox. Initially it starts beating the fox, and then gradually the fox gets wiser about which way to move. So the demo then. If I can open this window so I can see everybody, if there's still people here. Let me see. Hold on. There's still 10 participants. Okay. So would you like to try these modules out? That's the first question. Can you indicate that? I'll stop sharing so I can see everybody. We had a couple of thoughts about this. One was that we would let you clone the REPL with all the modules in, and then try and investigate a module yourself. We could do that all together, or we could put people into meeting rooms. But I think, given we've got such a few number of people, we may as well all work together.
How's that? Is that better?
That's better. Yes. Yes.
Right. Sorry, it's too small. Sure.
Do you need to visit your Gmail account or your email account you're using in order to validate that you've set it up?
You can start using it without validation, but I think some features are limited, but you don't need to immediately validate.
Okay. That's it. You got it.
Yeah. Cool. This takes a bit of time to warm up, it seems. So in the home bar, there is a type in @CTM23. That's the name of the account we're using here. There should be more REPLs in the account than you see here: session A, session B, session C. Take a look at the session C REPL. When you click on it, you should get a page like this. And what we want to do is click the fork button, which is basically a term for copying to your account. So we go ahead and fork the REPL. You should see that in the top bar that it would copy to your name /session C to show that you've got a copy of it. And let me know how you get on that as well.
It's still pixelated, I'm afraid.
Still pixelated. That's unfortunate. It's been so well so far beforehand.
There you go. It's got it now. Yeah, it takes a while to. Okay, so the first thing to notice here is that these notebooks are your personal copy. Anything you save will be saved. Anything you change and save will be saved locally in the REPL.
I can't see anyone's got thumbs up or not at the moment, so let me know if you had difficulties, the people that are participating, or if you've succeeded.
I think you need to stop screen sharing in order to see everybody. Yeah. Okay.
Sure.
So Amy's got it working. Richard, how are you getting on?
Just up and running now.
Okay.
It's done it.
Fantastic. Okay, so there's one final stage to this. Let me just share a video again. So currently these notebooks are all password protected with a default password. There is an opportunity here to set up your own password. I'll give you the chance. I'll share this video here. So within the REPL, if you might see a tab labeled Shell to the right. If not, in the tools box in the bottom left, there is a Shell button. If you click that to open the shell, and there's a command that I'd like you to type in, which is Jupyter Notebook password. Hit enter, and I'll ask you to type a password and ask you to type a password again. Just type it here. There we go. And it might take some while to warm up, but eventually you'll say enter password, type, and the block of text would move. That's the next thing too, because it doesn't show the number of characters in the password, but it is typing the password in the background. So once you type the password, hit enter. You have to verify the password, hit enter. If you make a mistake, it'll say password don't match. And when it's correctly written out, you'll see wrote hash password to this JSON file.
Richard.
Oh, I can. Hang on a sec. Oh, sorry. Right. I can share mine. I'll show you where I've got to. I'm not sure if I'm in the right place or not.
That's good.
Here we go.
Okay.
So
Fantastic. Yeah, you got it running. So at the top right, you'll see a little web view button.
Next to the word
Um,
code search.
Ah,
Just a bit further
sorry.
down.
Thank you.
Yeah. And if you copy and paste that URL beneath the word web view into a new tab,
There's my new browser window.
fantastic. So if you type in your password, it should get the notebook open.
Here we go. Log in. Half a sec.
Okay. So
I'm not going to put in the keychain at the minute, but there we go. Mod 0. Here, Gatenio mod 0.
yeah.
Right, there it goes. Right. Oh, that's nice.
So this is the design of 7 units for Key Stage 2 Haskell.
Yes.
And it goes through, as you scroll down the background to the pedagogic approach, the very first lesson playing with the rods, making observations about their properties, and then giving them number names depending which rod they're measured with.
Yes.
And there is no computing involved in this first exercise, but there's a lot of mathematical writing. This unit is actually taught in Gatenio mathematics in the first term of the first year of primary school.
Wow.
What we did in year 2 was write, and we wrote up in Hello World, the magazine of computing at school, the 10 units that we did with the students who had this background, introducing them to Haskell programming. Anyway, that's the beginning. If you go scroll down to lesson 2.
Okay, lesson 2.
Now this gets very busy. For the teachers, we introduce mathematical and computing technical language.
Yes.
So a namespace is a collection of names. Property is something attributed to an object. An action reflects the structure or the verb and what you do with the objects. These rods have a property color. We have an object rod. We have an object of train, which is 2 rods put together. And then there's a whole bunch of technical language that comes bundled with Haskell. Although, as we've seen before, the language is also used to describe Python, some of it. The diagram there is cut from the standard Haskell classes diagram in this 98 Haskell standard. And it shows the way that the types, int, integer, float, double, are grouped into type classes, num or real, which captures their properties as a set of number types. The first thing we do is we create the color data type, which if you move down a little bit more, we show how to do that with type constructors, and then we inherit from the type class various implementation, such as the show function or the equal function.
Sorry. There you go. Sorry, I was too high up.
No, that's fine. If you select cell 1 now and run it,
Run.
and then what we need to do is clear out. So under cells, under the cell menu.
Under
If you
this.
hit run again, it'll fill in.
Sorry.
Yeah, but let's clear it first. And I know it's a bit risky. Clear all output at the bottom there.
All outputs.
Clear. Yeah.
Clear.
Okay, so now we need to go back again and run cell 1.
That's cell 1.
That's called a sum data type. It lists all the constructors in order and it derives properties from.
Right. Right. Cell 2
show.
as well.
Now you want to do. What do you think number 3 executing this next cell is going to do?
Test this by running with the following. Print red. Am I right in thinking that it's going to print the properties for the red Cuisenaire rod? It's asking whether the second rod is white, but you're asking, is it red?
Mhm.
That would return false.
Mhm.
The next one is it's got a white rod, and it's asking, is this rod white?
Mhm.
Then are we assigning the color green to a red rod?
No,
So
that symbol less than or equal to is a predicate, which you get free,
right,
which tests the order,
test the order, right?
because we've got deriving ord, which means all those constructors are ordered.
Yes. And then 3 plus 3. Hang on, what's 3 plus 3? Success, 3 value of success.
The successor function was something that the year 2 children were very happy with working with.
Yes.
Yeah.
I don't.
Ian, did you say were very happy or were not very happy?
They were very happy with it.
Okay.
Yeah.
Yeah.
In fact, we gave them the dollar sign as a way of composing functions, and they started writing expressions such as successor of successor, successor dollar successor.
Oh,
You could try putting that in now, and we'll can you edit that cell, Richard?
yes, I'll try. So just after 3 plus 3.
Yeah, on the next line.
Okay.
Put successor dollar space dollar
Space, sorry, space,
Yeah.
dollar, space,
space successor brown.
brown. Okay.
Okay, now try running the whole lot. If the demo gods are on our side, we'll be okay.
Yes. Red, false, true, true. Yeah, because red becomes before white, red, green. 6, yes. Successor, orange. 4, red.
So successor of brown.
Successor,
what?
yeah.
Successor of brown is blue, successor of blue is orange.
Orange, yes.
And of course, the next thing the children did was they typed in successor of orange. Try that.
Okay. Can I just stick it down here?
Yeah.
Successor of orange.
Mhm.
Is this going to loop around or is it going to fail? I'd guess it would fail. I'm just going to run it again. Stacks. Oh, and yeah, it's a stack out. It's gone off the end.
Yeah.
Yeah.
Okay.
That's interesting.
And they like breaking things, basically.
That's really good because that's what we're seeing at secondaries. They don't like breaking things.
I think they're much more open to learning in Key Stage 1.
I had an interesting experience of moving between a boys' school and a girls' school, sort of between second and third schools of my career. And the boys seemed very, very keen to break things, particularly by network and all of that. This willingness to try things out. Whereas the girls, possibly stereotyped, were really very worried about anything going wrong. You know, part of my role was encouraging them to try things out and learn from mistakes and so on. N equals 2 is not a reliable sample size, but I thought it was an interesting observation.
No, that more or less matches my experience as well. There was a heck of a lot of noise in the classroom. They all had their own iPads with an IDE for Haskell on when they were doing this exercise. And they were invited to play around with it and ask questions. And there was a lot of question answering being done of each other and of the teachers and teachers' assistant. It was a very lively classroom.
That's great. Yes.
I think if we go back to file open.
Okay, back to file open. Okay, so am I going back to the original window or
You're going to the toolbar there. That's it, yeah. File open. That gives you the directory structure again.
Yeah.
I'll quickly go on to mod 1.
Mod 1. I think I might have tapped it twice. Hang on.
That's okay. Fine. And if you scroll down, let's see how we get on doing this together.
Okay. So that's the cherry ball.
That's the problem, yeah.
Yes.
So if you just go to the cells now,
Right, okay.
so the first one is introducing a new data type
Yes,
called ratio. And the colon T is an instruction to the interpreter to tell you the type of the expression that follows.
Yes.
So A is being defined as 1/2, and its type is a fractional.
Yes, so that should give us.
Yeah.
Yes, brilliant.
So the next thing to do in 3 is to ask the successor of a rational.
Yes.
And this is a contradiction between the Haskell standard and mathematics, because the Haskell standard, as you can see there when you run it, will give you a successor of a rational number by adding 1 or subtracting 1 from it.
Yes.
But the aside that I've got at the top there says
Yeah.
Rationals are not sequential, because you can always interpose another rational between two rationals.
Yes.
So that's one kind of proviso to point out that although it looks like mathematics and it quacks like mathematics, it isn't actually mathematics.
Yes. There was always going to be something.
And then just to illustrate that again, if you take word as a data type, I think it's 2 to the power 32 in cell 4. It does some strange thing if you negate it, because a word isn't a typed integer.
Yes.
Anyway, coming back to the problem, the key to this solution to this problem is the type rate per minute. And you have to define the type by executing cell 5. Cell 6 is another interesting aside about how you were asking whether the colors names wrapped round. Well,
yes,
they don't, but integers do. So 2 to the power 64 is the same thing as integer 2 to the power 64 is the same thing as 0.
Wow.
And now I'm asking you to fill in one line to work out.
Right.
So you start by defining the two functions you need,
So
which are working together per minute. Sorry, working together per minute is going to use the other two functions.
Yes. So we need a rate per minute.
Yeah.
And we need a combine. Right. Okay. So let's see if I can do this. We've got rate per minute. How am I going to pick that? This is where my Haskell is very rusty at this point.
Well, let me help you. Working together per minute. The next line equation is going to be working together per minute, and then it's got two parameters.
Yeah.
M and N.
M comma M, isn't it?
It's very sparse, the syntax of Haskell, so you don't have anything, but you have to put as an aside. Haskell has two integer types. Yes.
Yeah.
Working together per minute, MN equals something which is a rate per minute.
M divided. What would I say? It's basically the number that if these are the number. I'm gonna. Are these going to be rates or are these just integers?
They're going to be rates.
Yeah.
Right. So I need to define. So that's going to be so many of it.
See, this is the interesting bit. You've got two rates per minute, and what you're going to do with them, it's differentiating between the syntax and the semantics.
Yes, and I've got lost somewhere between the syntax and the semantics.
Thanks, Heather.
Sorry?
I'm just saying thank you to Heather. She's leaving. Yeah.
Yeah. So what am I going to go off with?
They're working together.
Yes, it's the. Hold on. I'm just going to grab a piece of it.
This is very unfair to put you on the spot like this.
Oh, absolutely.
Jim, we're going to run out of time, and we can't run out of time because there's another session, I think. or even if there isn't, I don't think we should do that. Jim, do you want to jump in with an answer there?
M plus N, they're working together, so you add their rates. But remember, this is the rate, not the how long it takes to do 100 or whatever.
Okay.
Yeah, that's what I've just written down. I got there. I got there. Right, so I'll just press run and watch that fail.
Okay, you've got that defined.
Right, that's defined. So now, what's the next step? This uses how long it'll take them to fill the ball together. Okay.
So you've got a rate per minute, and you've got to go rate per minute to minute.
For minutes.
Or minutes, yeah. It's interesting because you haven't got in there how many cherries are in the bowl.
That's what's causing me problems.
Do you need to know how many cherries are in the bowl?
It would need to be a parameter, I'm going to argue.
Yeah,
You've got a rate per minute. You need to know how many you need. I think the argument list is wrong. Sorry, I'm trashing your talk. I do apologize.
No.
Shall we put her thing in for a number of cherries?
I think so, yeah.
Yes. Can I just add another parameter in there?
Well, you'd have to change the type signature. I think the fact that the hint is suggesting that you don't do that.
Okay.
We probably need to move on to the next line.
Oh, sorry.
Sorry.
I'm talking to the cat. She's on the keyboard. I forgot.
How can you confirm? How can you convert the rate per minute that they're doing together to the total time it's going to take them to fill it?
You need to know the number of cherries.
No, I don't think you do, Jim.
Sure?
I think that's a red herring.
Yes. And is one chap was working at 48 per minute.
Reciprocate.
Thank you, John.
Thank you.
You can rely on Manchester Grammar School to come up with the answer.
Right.
I think this is the first time I've seen this problem.
Ah,
Right. So
working together time.
yes, working together.
That's per cherry, though, isn't it? I think we're arguing semantics here.
Okay, so now you want to put in the parameter n, which is your rate per minute, and then equals what the function maps to. That's it.
All that.
Oh,
Like that?
No, I think it's just n over n.
M over n.
no, just n. No, just n.
Yeah, 1 over n. So that's how long it takes to do one cherry, and you need to multiply that by the number of cherries, I'm going to guess.
Okay. Oh, hang on. Oh, n. Oh,
Yeah.
yes.
So this is a bit like the Thonny app at IDE. The iHaskell interpreter that's sitting behind the notebook is giving you some help with syntax and semantic errors. So now try running the next one to define cell 9.
Yes. Just run that.
And now try testing it. Okay.
So 6 per minute. 6 minutes. So, done. Right.
Does that sound right?
Yeah.
Yeah, I think so. I'm going to play with this on paper over lunch.
Brilliant. And isn't that exactly the attitude we want, actually, that whole concept of I'm going to play with this. I would argue that's critically important.
Yeah.
Yes. I don't think yeah. See, we don't actually need to know the number of cherries in the bowl.
No.
I'm amazed.
No. 1 over 8 plus 1 over 24 is 1 over 6.
Yeah.
So the combined rate is a sixth. The fill a bowl together in 6 minutes.
Yeah. Oh, that's amazing.
Thank you so much for being a
1/8 is 3 over 24 plus 1 over 24 is 4 over 24, which is 1 over 6.
Yes.
Oh, it's all to fill the bowl,
So the
isn't it? It's not
combined rate
dependent on-
is 6
Yeah, yeah.
minutes,
Yes.
and
Yeah.
it doesn't matter how many cherries are in the bowl.
Because
That's-
all the thing from the top was actually to fill the bowl. It wasn't. Yeah, I got confused on that. I thought there was
Yes.
a specific number of cherries. Yeah, it's to fill the bowl time, isn't it? Yeah.
But
It's the
what's
bowl.
interesting, if you go back and read Sasha's paper, which is as part of the CTM 22 report, when he's talking about his questions procedure, he does actually invent a magic number 72 to work with, and it comes out of nowhere. And as
Yeah.
you've just pointed out, you don't actually need that to work for a general purpose solution.
No, that's amazing. That's really interesting, actually.
Okay, well, I think we've run out of time, and Miles has gone, Heather's gone, so we should let ourselves go and have some lunch, I think.
Okay, next one at 2, is it?
I believe so, yeah. We have
Yes.
an hour for lunch.
Right.
Okay,
Yeah.
See
see you
you
then.
at
Okay,
lunch.
thanks.
Thanks,
Bye.
everyone.
Right. Cheerio.
Bye.
Bye.
Yeah.